Hi gang, sorry I'm not here. I'm at chemo today. However, today we're starting a new section. It's section 10.6 on right triangle trigonometry. You will need a calculator because these are awesome. And yeah, it's SoCatoa will be your friend. I'll write it on the board before I leave today. And I tried to find a funny song video, but there's a ton of them out there, and I didn't really find one I liked better than any of the rest. So if you find one that you like better than any of the rest, please send it to me. Okay, so let's get started. Trigonometric ratios are sine, cosine, and tangent. And they're really teeny tiny down there. And they have to do with if this is your angle, the side opposite the angle, the hypotenuse, which is the side across from the 90-degree angle, the longest side, and the side adjacent. It's important to remember that adjacent, seriously, the definition of adjacent is pretty darn close to it means next to. Okay? So adjacent is always the side next to the angle that you're looking for. Opposite means all the way across from it, and the hypotenuse is the long side. So I'm going to write these out a little bigger so that you can see them a little better. We have sine of theta, which equals the opposite over the hypotenuse. That's the so part. Then we have the ca part, which is the cosine of theta, equals the adjacent over the hypotenuse. And then we have the TOA part, which is the tangent of theta, is equal to the opposite side over the adjacent side. So sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. This will help you find values. So let's move on to some examples. So it wants the values of the sine, the cosine, and the tangent for angle A. The first thing we have to do is figure out, hey, we don't have the length of the hypotenuse. Fortunately, good old Pythagorean, who was afraid of beans because they made you fart, and if you fart, you let a little bit of your soul escape. Just a little interesting tidbit about Pythagoras, who was a seriously weird dude. But okay, so little a squared plus b squared equals c squared. C squared is always going to be the hypotenuse. A and b are either side. So I'm just going to call a 12 and b 5. So we have 12 squared plus 5 squared equals c squared. 12 squared is 144. 5 squared is 25. 144 plus 25 is 169. If you take the square root of both sides, you get 13 equals c, because the square root will cancel out the squared, and the square root of 169 is 13. It's important, and I just happen to have a highlighter on me, to disregard the negative root. The negative root, because when you take the square root of 169, you get 13 and negative 13, but the distance of this length can never be negative, so ignore the negative. Okay? So now that we have discovered what the length of our missing side is, 13, now we can write each trigonometric ratio. So we're looking at angle A, that's this angle right here, So the adjacent side is the side next to A, and the opposite side is the side across from A. So our opposite side is 5, and our hypotenuse is 13. That was a little bit of a mouthful. So that's the trigonometric ratio that will give us sine of A. We don't have to do anything else with it. Cosine is the adjacent over the hypotenuse. So it went way blurry there. Cosine is the ka. So we do the adjacent, which is 12, over the hypotenuse, which is 13. Then for tangent, we're going to do the opposite over the adjacent. And that is literally all you have to do to solve those kind of problems. Next, we're going to go a little bit more difficult, but not terrible. Trigonometric functions can be used to solve problems involving right triangles. So, example, if P is 35 degrees, there's P right there, and R is 14, let's find Q, which is right there. So, we know the measure of an angle and the hypotenuse, because this is the hypotenuse. We want to know the measure of the side adjacent to the given angle. Here's our angle. This side is adjacent to it. It's right next to. This would be opposite. Which function relates to side adjacent and the hypotenuse? Well, if we look at SOHCAHTOA, which, okay, my hand didn't want to write there. So, opposite and hypotenuse are so. Adjacent and hypotenuse, hey, that's cosine. All right. So cosine equals the adjacent and the hypotenuse. So cosine, this time we know what our theta is. It's 35. And that's going to equal our adjacent, which is Q, over our hypotenuse, which is 14. Now, there's two important things going on here. 14 is on the bottom of the fraction bar. Fraction bar means divide, so we're going to have to multiply by both sides by 14 to make that go away. So we get 14 cosine 35 is Q. The second important thing to remember is in your calculator, you want to check and make sure, well, first you want to make sure it's on. Let's clear that all out. Okay, so we want to check and make sure, because our problem is given in degrees, that we check and make sure that our calculator is going to give us an answer in degrees. So you hit the mode button, and then right here it says degree and it's highlighted. So I'm good to go. So second quit. If you're not good to go, you'd have to scroll down and hit enter to highlight that. So then we can put this right in our calculator. 14, let me push this down here, maybe that'll show it better. Good. 14 cosine, whoops, let's try that again. 14 cosine, the cosine button is right here. Sine, cosine, tangent. So 14 cosine 35. Enter, and we get a big number, which I think Math Excel has you round to the nearest tenth. And it doesn't say in our problem, so I'm going to say round to the nearest tenth, which would be 11.5. Okay, so let's try another one. So if we have J is 50 degrees and little j is 12, find R. Well, you might notice that R is directly across from the 90-degree angle, and it's the longest side, so that's the hypotenuse. here's our 50-degree angle. This is the adjacent. This is the opposite. So we're looking for something that deals with the opposite and the hypotenuse. Looking back at SOHCAHTOA, the opposite and the hypotenuse are sine. So we're going to use sine. So sine theta is opposite over hypotenuse. We know our theta, that's 50. So sine of 50 equals our opposite side over our hypotenuse. Now, we have r on the bottom. So we need r off the bottom. So we're dividing by r, so let's times both sides by r. That cancels. So we get r sine 50. R times sine 50 equals 12. But we want r all by itself. We don't care. Get rid of that sine 50. So we're going to divide by the sine 50. And we say r equals 12 divided by sine 50. And right there, we hit that stopping point where we can say 12 divided by sine 50, and enter. And if we round that to the nearest tenth, we're going to get 15.7. All right, let's try another one. Okay, inverse trigonometric relations can be used to find the angles of right triangles. Okay, this gets a little bit confusing, but hopefully not too bad. So, if we have F is 17, that's way down here, and D is 32, find E. So we have the side adjacent and the hypotenuse. So once again, we're back up. You guys can't see that. SOHCAHTOA. So adjacent and hypotenuse is going to be cosine. So we're going to use cosine. Now, we don't know what E is. So we're going to say cosine of E equals the adjacent over the hypotenuse. And then we're going to use the inverse function, because if you do the cosine inverse of the cosine of E, because we're going to do it to both sides, so the cosine inverse of the cosine of E equals the cosine inverse of 17 over 32. What you'll find happen is the cosine inverse and the cosine on that side cancel out, and you get E equals cosine inverse of 17 over 32. And you can just leave that as a fraction. You don't have to divide it all out. And then you get out your calculator. Let me scooch this so you can see what I'm doing at the same time as I'm doing it. Okay? And then you just go, okay, so you go second, and then right above cosine is cosine inverse. I'm not sure if you can see that. Ah, there we go. So see how it says in blue cosine inverse right above the cosine? And it'll do that. And then you just do 17 divided by 32, close parenthesis, and we get our answer. And I'm pretty sure Math Excel will have you round things to a whole degree. So then we end up with E is 60 degrees. Okay, so 2 more. You can use trigonometric functions and inverse relations to solve right triangles. To solve a triangle means that you find all of the measures of its sides and angles. Usually 2 measures are given, and then you can find the remaining measures. Whenever possible, use measures given in the problem to find the unknown measures, because you could make a mistake. So Use the ones that they give you. So let's do one. So solve the following triangle. A is 33. Little b is 5.8. Find capital B. Well, hey, C is 90, A is 33, so we can just kind of go over here and say 90 plus 33 is going to be 123. And then we say 180, because all triangles add up to 180, minus 123 will give us 57. We can check that on our calculator. 180 minus 123 is 57. So B is 57. So then it says find A. Well, little a is opposite 33, and we have the adjacent, so we can use tangent, because if you look at SOHCAHTOA, if you have the opposite and the adjacent, you're looking at tangent. So our tangent of 33 is going to equal A over 5.8. Oops, I lost my point. So we're dividing by 5.8, so we times by 5.8. And what we end up with is 5.8 tangent 33 equals A. So let's get the calculator back out here. And we say 5.8 tangent 33. And we get 3.8. All right, then we find C. For C, that's the hypotenuse. Let me write 3.8 over here. The hypotenuse and the adjacent, we're going to use cosine. So we say cosine 33 equals the adjacent, so that's 5.8 over C, which then we're going to have to times by C to get it off the bottom, and we get C cosine 33 equals 5.8. Now these are times, so we want to get rid of that cosine 33, so we divide by it. Those cancel, so C equals 5.8 divided by cosine 33. So we use our handy dandy calculator and do 5.8 divided by cosine 33. And our answer is 6.9. And that's all you have to do.